Hello everybody. In this video, we are going to be rationalizing the denominator. Now, the whole point of this topic, I know it's very obscure, but it's very important most of the times, especially when you're doing maybe trigonometry, proving this and that, and doing limits in whatever in university, all of those things, right? There's actually many uses for rationalizing denominators, and we will be going over the two ways on rationalizing denominators. So the first way is going to be the simple one, but the question is, how do we know when to actually apply this? Now, if you say, for example, we have maybe a whatever on the top, right? Anything on the top, but then you have some square root at the bottom, right? Let's say square root of b, okay? But the thing is, we don't like the square root in the denominator, right? So this is where we have to rationalize. And in order for us to rationalize, we need to understand how do we get rid of the square root of b. Now you'd probably say to square both sides, right? But the thing is, we don't have an equation. So we can't really do anything right now because you can't just square it and say it's the same as a over root b. That is not true. So therefore, what we actually have to do is the following. We are going to multiply by whatever the denominator is, right? We're going to write it as the square root of b over the square root of b. Because notice that this is just equal to 1, right? Because they cancel. So why does this help us? Now notice when we do simplify this from this step, then notice we're going to have a multiplied by square root of b over square root of b multiplied by square root of b. And remember, with surd laws, whenever we have the square root of a multiplied by the square root of a, for example, we can actually write it as the square root of a times a. Okay? We can because they both share a square root, and according to surd laws, if you want to look at it in this way, as a to the power of a half multiplied by a to the power of a half, notice that the bases are the same and exponent laws of addition is applied since we are multiplying. So it's going to be a to the power of a half plus a half, okay, which is just going to give us a to the power of 1, okay, which is a. And notice if we continue here, we are going to have the square root of a squared. And for high school purposes, I'm not going to do absolute values, but I'm just going to say that they cancel and they'll also give a, okay? So you can either do this method or you could do the top method where you use exponent laws. So either surd laws or exponent laws, those are the two methods that you can use, okay? But otherwise, let's get further on with this one. So let's use surd laws just to make it easier. Okay, so notice what happens over here. We're going to have a square root b because they're multiplying. And then square root b times square root b is just going to be the square root of b squared, right? Where the squares will cancel. And then we're just going to have a root b over b. And notice what we've just done. We got rid of the square root. Here was a square root, but here's no square root. And we don't care about the numerator, just as long as we don't have a square root in the denominator. So that's the whole point of the rationalizing denominator thing. Let's actually do some examples to see how this has worked, because obviously I showed you a general idea on how to do it. Okay, so here's the first example. We need to simplify by rationalizing the denominator of 6 minus the square root of 5 over the square root of 8. Now here's the thing, right? Remember, there is a square root over here, right? But we don't care about the square root in the numerator. We more focus on the denominator. Why? Because the question said so. And this is literally the topic, rationalizing the denominator. So we're going to do exactly what we did, right? We need to multiply by the denominator over itself, okay? So we need to multiply by square root of 8 over square root of 8. Because why? This is going to give us 1. Okay, so we are allowed to do that. So that's the whole point, right? In order for us to get rid of the square root, we need to basically multiply by 1. Okay, so I'm going to show you the steps in which you can actually look at it, right? So let's do it this way, right? If you're going to do it in an examination or wherever you do it, or your homework, let's see. So if you have to start off here, you're going to say this part here, and then you're going to show your step. So 6 minus the square root of 5 over square root of 8 multiplied by 1. Okay. And then we can say over here that 1 can be equal to the square root of 8 over the square root of 8. I'm just showing all the steps. You don't have to always do this. Then it's going to be the same as 6 minus the square root of 5. And notice this is multiplying by the square root of 8 over square root of 8 multiplied by the square root of 8. And notice that obviously this part comes from here. And then all we need to do is simplify, okay? So if we take the square root of 8 into the bracket here, we are going to get 6 times the square root of 8 minus the square root of 5 times the square root of 8. Remember, that's just going to be the square root of 5 times 8 using surd laws. And then the square root of 8 times the square root of 8 is just the square root of 64, okay? Because it's the square, I'll just say the square root of 8 times 8 for now, okay? From here, we can just keep simplifying, but here, we can reduce this one, but actually I'll show you how to reduce it. It would be much better. I don't know, some teachers won't really like mark that part about reducing it, but just to show you how to do it, let's do it, okay? So notice that we can break up 8 into some perfect square multiplied by another value, which is 4 times 2, okay? And then we can say here, times the square root of 5 times 8, which is going to be 40, divided by the square root of 8 times 8, we are going to have over here as the square root of 64, right? And then here, notice that the square root of 4 times 2 can also be written as 6 times the square root of 4 times the square root of 2 minus, and then this one we can do the exact same thing. We can say here, this can be written as 4 times 10, right? So we can get a perfect square. And then the square root of 64 is just 8. Here, we notice that the square root of 4 is just 2, so 2 times 6 is just equal to 12. So it's 12 times the square root of 2 minus, it will be 2 times the square root of 10. Because notice that this is just the square root of 4 times 10, which is just going to be 2 times the square root of 10. And then here we have it divided by 8. And if you want to simplify any further, since this can be the final answer, but if you want to simplify it one more time, you can take out 2 as a common factor. Because notice that we have a 2 here as the highest part of the, as the lowest. Okay. So meaning we can take 2 out as a common factor from the numerator. It'll be 6 root 2, and then it'll be minus root 10, okay? Divided by 2, take away from 8, which is 4, okay? And then notice we can cancel this out, and then we're left with 6 root 2 minus 10, root 10, sorry, divided by 4. And that is how we rationalize it. Now, I know I did quite a bit of steps, but obviously when it comes to simplifying as much as possible, you kind of need to know your surd laws. Otherwise, you could always just reduce it down to exponent laws like I did here. Then it will make life easier because I think you know exponent laws better than surd laws most of the time. Otherwise, let's get to the last part of the rationalizing part, because remember, all we need to do is get rid of the square root in the denominator. So the last type of rationalization of denominator question that I want to do for example 2, okay? We need to rationalize the square root of 6 minus the square root of 2 over the square root of 6 plus the square root of 2 fully. Now here's the trick, right? Whenever you have something like this, okay, all we need to do, okay, is use something called a conjugate. Now, what is a conjugate? I'm going to write here on the side. Let's say, for example, we have A plus B, right? This means that the conjugate is going to be A minus B. All we simply did was just swap the sign. Okay, meaning it can work vice versa. The conjugate of a minus b will be a plus b. Okay, now why does this help us? Okay, in this case. Now, whenever we have a binomial term, right, we have two terms, okay, in a denominator instead of one, because the last example we just had the square root, just one term in the denominator. But now we have two, so this is a little bit more tricky. So now this is where we use conjugates, and I'm going to show you why it works. So we have the square root of 6 minus the square root of 2 over the square root of 6 plus the square root of 2. And we are going to multiply, just like we did in the first one, just by the denominator dividing itself, except we're going to use the conjugate dividing itself, okay? Meaning, we are going to take the square root of 6 minus the square root of 2 over the square root of 6 plus the square root of 2. But then we're going to multiply by the conjugate, okay? Meaning, we are going to multiply by the square root of 6. The conjugate of the square root of 6 plus the square root of 2 is just the square root of 6 minus the square root of 2. Why? Because we are going to change the sign to a minus. And that is what the conjugate is. Okay. So it's going to look like this. It's going to be the square root of 6 minus the square root of 2 over the square root of 6 minus the square root of 2. So that we can make sure we keep this equal to 1. Okay. So that it works in the equation or the expression. And then all we do is you just multiply the fractions now, okay? So we're going to have the square root of 6 minus the square root of 2 multiplied by the square root of 6 minus the square root of 2, all divided by the square root of 6, I'm just zooming a little bit over here, the square root of 6 plus the square root of 2 multiplied by the square root of 6 minus the square root of 2. Now I'm going to show you why this works. Because if you remember something called difference of two squares, right, we need to remember something called dots. Difference of two squares. Okay, and what does this imply to us? Every single time we have a difference of two squares, such as a squared minus b squared, this can be represented as a minus b times a plus b. Or you can say a plus b times a minus b, whatever, right? But do you notice that this kind of is in the form over here in the denominator? Notice that square root of 6 and square root of 6 is just represented by a. And square root of 2 and square root of 2 is represented by b. And then you just see the signs over here, right? The signs kind of correlate to what we have here, the plus and the minus. Therefore, we can use the dots knowledge to rewrite it in this form, a squared minus b squared. Okay, now it's going to look something like this. Since we know a is equal to square root of 6 and b is equal to square root of 2 according to our dots, this is what it's going to look like. So we are going to have the square root of 6 minus the square root of 2 multiplied by the square root of 6 minus the square root of 2 divided by, it's just going to be a squared, which is the square root of 6 squared minus, remember it's dots, it's difference of two squares, the square root of 2, which is b squared. Okay, and then now we simplify it, right? We can obviously use FOIL method over here as well. So square root of 6 times the square root of 6 is just going to be the square root of 36. And then we are going to say the outer, so it's going to be square root of 6 times negative square root 2, which is just going to be minus the square root of 6 times 2, which is 12. And then here we are going to have the inner, which is going to be minus square root of 12, and then it's going to be plus square root of 4 for the last. And then here, the square root of 6 all squared is just going to be 6 because they cancel out. Okay, so let me just write that in red. They cancel. And then here, the square also cancels with the square root, so it's going to be 6 minus 2. Okay. And then from here, we can actually simplify the numerator. The square root of 36 is just 6. And then minus square root 12 minus square root 12 is just minus 2 square root 12 plus square root of 4, which is 2, divided by 4. And then from here, it would actually be easier to simplify this part over here, right? So we're going to have 6 plus 2, which is 8. 8 minus 2 root 12 divided by 4. Okay. And then let's see over here, right? We can simplify this third part further. So obviously this is sometimes optional, but I would still recommend doing this because maybe that extra bonus mark or last mark is from there. All you need to do is just say 8 minus 12. Can we get a perfect square from that? Yes. We can actually break 12 up as 4 times 3, right? And 4 is a perfect square, meaning we can write it as 2 times 4 times 3, right? And then over 4. And then 4 can be written, or square root of 4 is just 2, so it's 8 minus square root of 2 times, square root of 4 times 2, which is basically 2 times 2, which is 4. So we are left with that. And then we can take out 4 as a common factor, meaning we're going to have 4 here as a common factor, and then we're going to have 2 minus root 3 over 4. The 4's can cancel out, and then all we are left with is 2 minus square root 3. Doesn't that actually look much better? Look at what we just shaped it as now. So this used to be some messy looking fraction, but we rationalized it, and now, after rationalizing it, we just have 2 terms here, and we got rid of a fraction. Isn't that amazing? So that is how we rationalize denominators.